Hello, sixth grade, and welcome to 4.1. Today we'll be discussing factors and prime factorization. All right, this is the first lesson in chapter 4, which is titled Number Theory in Fractions. All right, we want to be able to write prime factorizations of composite numbers today. So, kind of some big terms here, but we'll get some practice and we'll do a little defining of those to start as well. So the first vocab word that we have is a factor. And if you remember, a factor is a number that is multiplied by another number to find a product. Okay, so an example of that would be like, let's say 2 times 3 equals 6. The factors of 6 would be 2 and 3. Okay. And the second vocab word is prime factorization, and that's a number written as the product of its prime factors. Okay, and keyword there being prime. If you don't remember what a prime number is when it only has one and itself as factors. So some of the more common prime numbers would be like, examples of prime numbers would be like 2, because 1 times 2 are the only factors of 2. 3, because 1 times 3 are the only numbers that multiply to get to 3. 4 is not, because you'd have 1 and 4, and also 2, because 2 times 2 is 4. 5 is a prime number. 1 times 5 is 5, and that's it. 7 is a prime number. A lot of times people think 9 is a prime number, but remember 1 times 9 is 9, and also 3 times 3. So 9 is not a prime number. Okay, so a prime factorization is a number written as the product, so multiplying its prime factors. And I'll be sure to go over quite a few examples of prime factorization as well. Right? Let's start with example 1, where we look at just factors to start. So where we're trying to find the factors of a number. Okay, it says list all the factors of a number, and the number that we're going to try to find the factors for is 16. And here in the example, they use a vertical method. I like to use a horizontal method. I'll show that in just a minute, but first I'll do the vertical method here. So begin listing factor pairs. Well, 1 and itself are really good to start with. So I would write this down, start with 1 and itself. So for example, 1 times 16, right? 2 is 2 a factor. Then work your way up. Yep, because 2 times 8 is 16. 3 is 3 times anything 16? No, not a whole number at least. So 3 is not a factor. 4, yes, because 4 times 4 is a factor. 5 times something? No. 6 times something? No. 7? No. And 8 times 2, yes, that works, but we already have that. So we can stop here. So the factors of 16 are, well, we said 1 was a factor. We said 2 was a factor. 3, no. 4, yes. 5, 6, 7, no. 8, yes. And lastly, don't forget 1 times 16. Okay, so the factors of 16 are 1, 2, 4, 8, and 16. All right, let's do another one. And I'll do the kind of the method that I prefer. Let's say 25. Find the factors of 25. Well, start with 1 in itself, so 1 times 25. Is 2 a factor? Well, is this an even number? Does it end with an even number? No, so 2 is not. 3, does 3 go into 25? No. 4, no. 5, yes, 5 is a factor because 5 times 5 is 25. And you just have to write it once. And we should be done because 6, no. 7, no. 8, no. We already met in the middle there. So there's only 3 factors of 25. It'd be 1, 5, and 25. Okay. Let's do maybe one more, and I'll do the horizontal method again. How about 24? The factors of 24. Well, 1 times 24, 1 in itself. How about 2? Yeah, 2 times 12 is 24. So notice how I write them kind of on opposite ends here, and I work my way to the middle. 3. Yep, 3 times 8 is 24. What's next? 4. Is 4 a factor? 4 times 6 is 24. Is 5 a factor? No. Is 6? Yep, but we've already got it. So quite a few factor pairs for 24. 1, 2, 3, 4, 5, 6, 7, 8 factors for 24. Okay. Hopefully you're starting to catch on a little bit. Let's do letter B, where it asks for to find the factors of 19. Okay. Well, start with 1 and itself. So 1 times 19. How about 2? No, it's not even. 3. No. 4. No. You could keep going, and you're not going to find any numbers in between 1 and 19 that multiply to get to 19, because 19 is not divisible by any other whole number. So the factors of 19 are only 1 and 19. 1 in itself, that would make 19 a prime number because its only factors are 1 in itself. Okay, go ahead and flip to the back side, and now we'll do an example using prime factorization. Okay, so the first method is the method that I prefer. If you like the second method, that's fine, but I like using a factor tree. That really helps me. Okay, it says choose any 2 factors of 24 to begin, and keep finding factors until each branch ends at a prime number. My reminder that I like to give students is break down your number using 2, 3, or 5. And the reason is because 2, 3, and 5 are all prime numbers. So I really like to start by checking if 2, 3, or 5 can be divided by whatever my number is. In this case, for 24, you'll see that they started with 2 in this example. This is just breaking it down differently. So here's the first one that they did, the first factor tree. They broke it down using 2. So they said, okay, 2 times 12 will give you 24. And I'm going to circle my prime numbers. Okay, well, they looked at 12 and they said, well, you can still break down 12 into 2 different numbers because 12 is a composite number. We can break it down further using some of its factors. So can we divide it by 2 again? Yes. 2 times 6. Again, I circled my 2. How about 6? Well, I can break 6 down into 2 times 3, and 2 and 3 are both prime numbers. So you keep finding factors until each branch ends at a prime factor. So 2 is prime, done. 2 is prime, we don't branch anymore. 2 and 3 are both prime, so now we're done. So when we write the prime factorization of 24, we would say it is 2 times 2 times 2 times 3. Sorry, I was cut off there, but let me write that for you as 2 times 2 times 2 times 3. All of my prime numbers. And again, let's double check. 2 times 2 is 4. 4 times 2 is 8. And 8 times 3, yes, that gives us our original number of 24. And these are all prime. Okay. This example here is showing you that you can break down any number using whatever numbers you want. It doesn't have to be 2, 3, or 5 like we did here. You could break down 24 saying, okay, well, I know 6 times 4 is 24. Perfect. But I'm not going to circle either of these because both of them are still composite numbers. I can still break down these two composite numbers even further. So what are two numbers that multiply to get to 6? What are factors of 6? Well, 3 times 2, and those are both prime, so I'll circle them. And 4 can be broken down into 2 times 2, and those are both prime, so I'll circle them. So I come up with my prime numbers would be 2 times 2 times 2 times 3. And you'll notice it's the same exact thing as I got over here. It doesn't matter how you factor out your original numbers, you'll get the same exact answer. Okay, so the prime factorization for 24 is 2 times 2 times 2 times 3. Or you could shorten that up because repeated multiplication we can write as exponents. So we can say that's the same thing as 2 to the third power times 3 because there are 3 2's here, right? That is using a factor tree. I like this method the best. We'll get lots of practice with it. There is another method when doing prime factorization, and that's using a ladder diagram. And you can use this one if you'd like. I prefer the factor tree, but I'll show you how the ladder diagram works as well. It says choose a prime factor of 45 to begin. So you could use 2, well, you can't use 2 because it's an odd number. You could use 3, or you could use 5 because it also ends in a 5 to break down 45. Okay, so they said 45, if you divide that by 3, you would get 15. Okay, we're still not to where we have 2 prime numbers because this is a composite number. It can be broken down again into 5 times 3. Okay, so 5 times 3 would give you that original this 15. Okay, so if you in the end, if you break down your number and you need to keep dividing until your prime factors receive a quotient of 1. So here you can see 5 divided by 5 is 1. Okay, then all you need to do is look at your numbers on the outside, and they tell you your prime factorization. So 3 times 3 times 5. 3 times 3 times 5. Okay, and it's the same exact over here as what they got over here. Okay, so 3 times 3 times 5. So the prime factorization is, it's getting a little repetitive here, or 3 squared times 5, because 3 times 3 is 9, and 9 times 5 is 45. All right. Again, I don't think this way is as easy to do. I'm going to show you the factor tree method using 45 as well. Okay. So if you were to use the factor tree, I would say, well, I'm going to use 5 right away. And 5 times 9 would give me 45. And I'm going to circle 5 because 5 is prime. And I can break down 9 into 3 times 3. Okay? And both 3 and 3 are prime. So I came up with the same thing, but to me it looks just a little bit neater. It's a little bit easier for me to follow. Okay, so that's I prefer this method, but if you like the ladder diagram, you can use that as well. Okay. Lastly is the check it out. So pause the video, see how you do, and then come back to check. All right, factor pairs for 12. We'd have 1 times 12, 2 times 6, and 3 times 4. All right, hopefully you did okay with that one. Let's practice. Let's also do prime factorization of 12. Well, that'd be 2 times 6. 2 is prime. And we can break down 6 even more into 2 times 3. Okay, 2 and 3 are both prime. So my prime factorization of 12 would be 2 times 2 times 3, or 2 squared times 3. Okay, I just added that one in there just for some additional practice. All right, first time seeing prime factorization is my guess. Get some practice with it. Let me know if you have questions, and I'll be happy to help. Good luck on the homework when you get there, and I'll see you next time.